So our next topic is the shear strength of soil. So yung pag-uusapan natin sa shear strength of soil is yung the shear strength of soil dahil dito sa direct shear test natin, and then yung triaxial test of soil considering yung apat na test na ito, yung unconfined compression, yung unconsolidated undrained, yung consolidated drain, and yung consolidated undrained test. So, shear strength. The shear strength of soil is the internal resistance per unit area that the soil mass can offer to resist failure and sliding along any plane of soil mass. So, if we have here uh, so we have here a soil particle, and then mag-apply tayo ng shear force. So, meron tayong shear force. This is also shear force. Yung sliding plane natin dito is meron tayong strength. So, meron tayong strength ng soil on our sliding plane or yung tinatawag nating shearing resistant nung ating soil. So we have here a soil, tapos meron tayong nakapatong na structure dito. Yung behavior nung ating soil is etong curve na ito, yung black curve na yan. So, meron tayong failure plane ng soil due to the load imposed by the building. So, syempre, yung building may load, so magkakaroon tayo dito sa soil ng stresses. So, meron tayong normal, and then meron tayong shear stress. So, yung shear stress, yung parallel doon sa ating force, and then yung normal, yung perpendicular. So, itong yellow is yung shear, yung red is yung normal stress. So, according to Moore, yung failure natin is because doon sa combination nung ating stresses. Hindi dahil sa isang stress lamang, kundi combination ng dalawang stresses. So, sabi niya dito, the presented theory for rupture in the material that contended that a material failed because of a critical combination of normal stress and shearing stress and not either maximum normal or shear stress alone. So, yung soil natin mag-fail due to the combination of the stresses, not yung hindi lang dapat yung normal stress or yung shear stress lamang. So we have here the functional relationship between the normal stress and the shear stress on a failure plane. This can be expressed by this given formula. Yung that is actually tau, hindi t. Yung tau is equal to the function of ating yung normal stress of the failure plane or yung ating sigma. So, this equation defined is a curved line. So, meron din tayo dito na equation to approximate the shear stress on the failure plane as a linear function of the normal stress. So, this function can be written as tau is equal to C cohesion plus sigma tangent of phi. So, yung symbols natin, ito yung mga notations niya. So, C is the cohesion, the P is the angle of friction, the sigma is the normal stress on the failure plane, and yung ating tau is our shear strength. So, the preceding equation is called the Moore-Coulomb failure criterion. So, meron tayong more column criterion dito. That is equal to sigma is equal to sigma prime plus the mu or the water pressure. Tapos, yung ating effective stress, that is equal to the shear is equal to C prime, yung cohesion doon sa ating effective plus the sigma prime tangent of V prime. So yung prime natin that is denoted doon sa ating effective stress. So pag walang prime yan, yung cohesion, yung sigma and yung phi, yung kinukuha natin is yung ating total stress, hindi yung ating effective stress. So, we have here the typical values of drain angle of friction for some granular soils. So, ito yung typical values natin for the value of phi prime. So, pag sinabi nating loose sand siya, yung phi natin is in between 27 to 30. And then, pag medium naman na sand, ang phi prime natin is in between 30 to 35. So, we have here the typical values of drain angle of friction for sand and silts. And then, we have here the more column failure criterion. So, meron tayo dito yung ating figure, ito yung failure plane natin, meron din tayong failure envelope dito. So, yung failure envelope natin, yung y-axis natin shear, yung x-axis natin is the effective normal stress. And this line represents our yung equation natin kanina, yung this line, itong line nakuha dahil doon sa equation natin kanina na tau is equal to C plus sigma prime tangent of the angle. So, ito yung more column failure criterion natin. So, we have here the inclination of the plane of failure caused by the shear. So, ito yung ating failure envelope, and ito yung failure plane natin. So, yung failure plane natin, yung theta natin, pag ililipat natin siya dito sa failure envelope, magiging yung phi na yung value natin. So, if we have here yung failure inclination natin that is derived from the equation tau is equal to C prime plus sigma prime tangent of phi prime. Yung itong line na ito, yung inclination niya. And then, ito yung Morse circle natin. Ito yung Morse circle natin. So, we have here the sigma 3, yung minor principal axis natin, and yung sigma 1, yung major principal axis natin or yung maximum principal axis natin. So, meron din tayo dito yung C prime, yung cohesion natin dito. So, take note, pag normally consolidated yung ating soil, yung cohesion natin is 0. So, wala tayong cohesion dito. So, andito yung line natin dito sa origin. Pero pag yung soil natin is overly consolidated, meron tayong value ng cohesion. So, meron tayong phi dyan, pag effective, phi prime. May prime yung ating value. So, ito yung ating failure plane. Ito yung ating failure envelope nung ating Morse circle. So, ito magiging diameter nito. So, sigma 1 minus sigma 3 is equal to diameter. Take note, yung values ng sigma 1 is from the origin. So, from the origin, papunta dito, yun yung value ng sigma 1. And yung sigma 3, from the origin din yung values niya, yung sigma 3. And then we have here the radius. And then yung failure plane natin dito is tangent doon sa ating Morse circle. So, makukuha nyo yung equation dyan if you use the trigonometry formulas. Yan. So, i-substitute nyo and then makukuha natin itong equation that is sigma 1 prime, yung prime, this is effective. and this is the total. So lahat nung may prime is the effective, and yung walang sigma, that is for the total. So makukuha nyo yung equation na ito if you use the trigonometric function para makuha yung values dito. So yung ito, yung diameter, ito yung radius. Pag nag-sign ka ng phi, that is over radius, tapos divide mo dito, makukuha mo din yung equations for phi. So, yan. And then we have here the laboratory test for the determination of shear strength parameters. Yung una is yung direct shear test, and yung pangalawa yung triaxial test. So in direct shear test, it is the oldest and simplest form of shear stress arrangement. So yung direct shear press apparatus diagram, ito is shown here. So the test equipment consists of a metal shear box in which the soil specimen is placed. So ito, meron tayong figure dito. Ito yung ating shear box. So meron tayong shear box, meron tayong base plate, tapos papatungan natin ang porous plate, yung solid grid plate, tapos ilalagay natin yung soil specimen, tapos tatakpan ulit natin ng solid grid, tapos porous plate and loading pad. Tsaka natin i-load doon sa ating direct shear test equipment. So, the size of the specimen generally used is about 51 mm or 102 mm. So, yung 2 by 2 or 4 by 4 inches across, and about 25 mm 1 inch in the height. So, the box is split horizontally into halves. So, yun yung ginagawa nung ating shear equipment. So, ini-split niya yung ating soil samples into half pag shear force dito sa ating specimen. So, normal force on the specimen is applied from the top. So, ito, from the top, pag nag-load tayo, meron tayong normal force from the top of the shear box. And then, the normal stress on the specimen can be as great as this value. Shear force is also applied moving 1/2 of the boxes relative to other to cause failure in the soil sample. So, the failure occurs along the plane of the split of the shear box. So, meron tayong failure dito, yung shear force natin. So, ganyan. Ganyan yung magiging picture nung ating shear box pag nag-apply tayo ng shear force. Ito yung magiging sample natin. So, magkakaroon tayo ng shearing resistance dito sa ating soil sample natin. So, yan din yung shear box assembly natin. And then we have here for the normally consolidated. So we have normally consolidated. Yung C natin is 0. Wala tayong cohesion. Pag cohesive, pag overly consolidated, hindi normally consolidated yung soil natin, meron tayong value ng C. Meron tayong value ng cohesion. So yung plot natin for the direct shear is that yung x-axis natin is the effective normal stress, and yung y-axis natin is the shear stress. So, pag i-plot natin yan, pag meron tayong sigma n, that is our normal stress, meron tayong shear stress, makukuha natin yung values ng ating shear strength parameter, which are the cohesion and yung phi natin na angle of internal friction. So we have here for the given test, yung normal stress can be calculated as the normal force, yung force natin over the cross-sectional area of the specimen. And for the resisting shear stress naman, that is equal to the resisting shear force, yung load na in-apply natin doon sa ating specimen over the cross-sectional area of the specimen. So that is for the direct shear test.